Very good morning to everyone. As part of our continuous improvement, we are going to learn today how to exchange packet between two different nodes using Python can library right now. So for that, we need two programs, node 1, node 2 like that. Previously, we had a mytest.py which contained a sample code to transmit the packet, and then using the same node we received the packet. Right now, whatever packet it transmits, it received it back and it displayed that in the screen. That is how we saw in the past. Now we are going to exchange packet in between two nodes. For that, we need two programs. That's why I created a copy of this program, and I call that as node 2. Right now, this is what our old program. Just I renamed that program to node1.py, which transmit a packet 110 with the periodicity with a periodicity of 500 milliseconds per seconds. Right now, each 500 milliseconds once, I will get a packet. Right, that's how it is. So now we have a node 2 which is having a same code, but only thing is there is a difference. We have a different arbitration ID which is 183, and data is also different. It has a 987 as data. Right. So now we are going to learn how these two programs going to exchange the packet. How this is going to work. Right. When the node 2 transmit a packet, right? No, node 1 transmit a packet, and node 2 is also running in the sense node 2 has a function bus.receive. Right now, the packets those are transmitted by node 1 as well as node 2 will appear in the RabbitMQ bus right now. So both of them will be there. So node 2, hence node 2 can listen what node 1 transmits. So it can get it and can display. Also, node 2 will transmit its own message. Right. So it transmits its own message that will also receive back. So in the screen of node 2, we will see both the packet, like the packet from node 1 as well as node 2. This will happen in node 1 as well, because node 1 is already transmitting its packet and receiving it back. So it will also get a packet from node 2 because it is listening to into the CAN bus. So it will get a copy of node 2 as well. So the both the program should display the packets of either node as well as their nodes. Right now, that's how it should work. Right. Let us see whether they are doing it. For that, let me run these programs independently in different command prompts. Let me close all these. Right. Let me bring command prompt now. Here I run Python node1.py. When I do that, I get packet of node 1. Right. So I get the packet transmitted by node 1, and it is received back by the same node, right? No, so it is doing transmission and self-reception. Right, this is the case. Now we have only one packet which is transmitted every 500 millisecond once. Right. Now let us introduce node 2. To run node 2, let me bring in another command prompt. There I run So when I run node 2, now I get two packets. One is packet of node 2, and then the packet from node 1 as well. So this happens in node 1 as well. See, if you look at the node 1 trace now, probably I think node 1 trace, why there is no, Okay, probably I didn't, it looks to me, it appears to me I didn't enable RX receive, bus receive in node 1. Let me check that. Yes, it is enabled. Then what happened? Maybe I think I didn't save it. That is the problem, right now. So let me stop and rerun node 1 once. So this is node 2, which is having the packet of both. This is node 1. But in node 1, I see only packet from node 1 only. It is not showing node 2 packets. So that I just, because I didn't save the change. So Python node 1.py. Now I see packet from node 2 as well as packet from node 1. So they are exchanging packet in between them. Right. As I told you before, the packet transmitted by both the nodes are appear in CAN bus. So each node can listen to it. If there is a packet, they can get it and can work on it if they want to work on it right now. So it is working. They are exchanging the packet in between them. Message receive callback. We are printing the received message, but it won't happen in every time. So maybe we can transmit our packet, but we won't print the packet always upon reception. So what we did is we created a example program or a independent program which can monitor the traffic from all nodes. So even it has an additional feature so that you can find the periodicity, you can validate the periodicity of the packet. You can display it in fixed position mode and chronological mode. We have all those features added to that. We can run that program instead of running individual trays in for every nodes. We run a dedicated trace which monitor traffic from all the nodes. Right. So where I can get that program is part of our Python CAN distribution, like the library distribution that we have. So go to our Python CAN, Ehasia Python CAN distribution. Come here in I think this is like our repository, right? Ehasia Python CAN. Here you go to example folder. In example folder, we have traffic.py. You can download that file to your the current working directory where you run your Python programs, right? And then you can run it, right? So just come here and hit this one so that you can get a copy of that file. You can put that in your working directory, right? Now, as I have that already in my directory, I'm just going to run that program in a separate window, right? So let me go there. I think I wrote this this program using Kinter so that you will see a GUI window. There you can see all packets information. See, there are two packets. Those are transmitted by two different nodes, right? Right. This is from node 1 and this is from node 2. We are seeing an absolute timestamp of that. And they are standard packet. And because it is received from those two nodes, that's why we have RX here. And then we also have their DLC and data byte value. Right now, I want to see the periodicity of, I want to verify whether they are received at the right periodicity. For that, we have an option here called relative. So the moment you select relative, they will display the relative time. As we see relative time in vector cannot trace, we can see the same here. Right, so we see, so this is transmitted at 250 milliseconds once, this is transmitted at 500 milliseconds once. Right, now that's how it is. We have written program in such a way that node 2 is transmitting 250 and node 1 is transmitting the packet at 500 milliseconds once. So now we get same thing in our GUI as well. Right, here is our trace. So now I can even change this to chronological so that I can see all as it is received. Right, even you can do that in this one. So this is at the initial stage. We want to add additional improvement to this. So like this, you can make the any option that you want. So this is like a centralized trace window where we can validate packets. Right. Okay, team. That's all for today. So today we learn how to exchange packet in between two nodes and then how to monitor packet from those nodes in a centralized traffic window. Okay, no. That's all for today. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.